this video, we're going to solve this problem, writing an equation and drawing its graph to model a real-world situation, advanced. So in this problem, we have scientists who are studying the temperature on a distant planet. They find that the surface temperature at one location is 25 degrees Celsius, so that's surface temperature. They also find that the temperature decreases by 3 degrees Celsius for each kilometer you go up from the surface. We want to let T represent the temperature and H be the height above the surface in kilometers. Write an equation relating T to H and then graph your equation using the axes below. So thinking about what is happening in this situation, I'm going to make a T chart of values here where I'm going to have the temperature and the height. Looking at my graph, I can see that height is the x-axis value here, and temperature is the y-axis. So I'm going to set up my table like that. I know that when the height is 0 kilometers above the surface, the temperature is 25 degrees. And at 1 kilometer above the surface, it's going to have decreased 3 degrees, so it will be 22. And then at 2 kilometers above the surface, it will decrease another 3 degrees, so it will be 19. So these are going to be some points that I can use to make my graph. As far as my equation goes, what I'm doing is I am taking the height, I am multiplying it by 3, and I am subtracting that from 25. So that's going to help me write my equation. My temperature is going to equal 25 minus 3 times the height, or h. So I would put that in for my equation. As far as doing my graph, I'm going to switch here to the actual problem. And when you're doing these problems, sometimes, like in this case, I can see that the scale of my graph is not necessarily going to let me plot the points that I want to plot. So I'm going to recommend using the plot a point feature here for these problems. It's going to be really helpful. So what I came up with already for my table is that height of 0 and temperature of 25 is 1 point. So I'm going to enter that into the plot a point and click enter or click plot point. And then another point that I can plot is 1 and 22. I only need 2 points to make a line, although I could continue plotting points if I wanted to. But once I'm done plotting, I can exit out of that and then click on the line tool to draw my line through those 2 points. And then once I've typed my equation in here, I can check my answer. So a couple of other problem types in this section that I want to talk about. This first one is a cookie company uses 1 cup of sugar for every 40 cookies it makes. So this one is a little bit different. A lot of the problems in this section will have sort of a starting amount, or basically it's going to be a y-intercept in the equation. This one does not have that. It's just 1 cup of sugar for every 40 cookies. So if I have 0 cups of sugar, I'm going to make 0 cookies. So in terms of my equation, relating S to N, S is the number of cups of sugar, N is the number of cookies. I multiply number of cups of sugar by 40. So if I have 1 cup, I make 40 cookies, 2 cups will make 80 cookies, etc. So I can write the equation this way. I can see that the way that this is written, the N is going to be the X variable, and the S is going to be the Y variable. Another way that I could write it if I wanted to was I could move the 40 over. And that would give me S equals N divided by 40. I think Alex will take either version of the equation. So that would be my equation for this. And then I could again use the plot a point tool to plot some points for this equation. And then finally, another example that's a little bit different is this one, where we have Layla driving on the highway. She begins the trip with 16 gallons of gas, and the car uses up 1 gallon of gas every 25 miles. So we want G to be the number of gallons of gas she has left in her tank, and D be the distance in miles that she's traveled. So this one, again, is a little bit of a challenge to write because what we have to think about is that we're starting with 16. So again, I'm going to make my table of values here. So when distance is 0, I have 16 gallons. The car uses 1 gallon of gas for every 25 miles. So when distance is 25, I'm down to 15 gallons. And when distance is 50, I'm down to 14 gallons. So what I'm doing here is for every 25 miles, I'm subtracting 1 gallon from the 16 that I started with. So my equation is going to be G equals my distance divided by 25. That's going to be subtracted from 16, or I could write plus negative 16 since I wrote that first. So 16 minus D over 25. So 100 miles, going to use 4 gallons, subtract that from 16, and I have 12 gallons left. So that would be the equation for this problem type.